Okay, and here's the answer to the quiz. So, if you take the utilitarian perspective, then you simply sum the different utilities. So in the first allocation, you get to a sum of 12, and in the second allocation, you get to a sum of 13. So from a utilitarian perspective, you should prefer the second allocation. If you take the Rawlsian perspective, you look at the person who is worst off, which in both cases is person A, but in allocation 1 he gets 3 units, and in the second allocation he gets only 2. So the worst person is better off in the first allocation. So from a Rawlsian perspective, using the Rawlsian social welfare function, you should prefer allocation 1. So far we discussed Pareto improvement and Pareto efficiency, so how you can reallocate units of goods, making some people better off without making anyone else worse off, but we only discussed it in a rather abstract way. And we're now going to do some specifics here, also relating these Pareto improvements to the underlying utility functions of the individuals involved. And this again brings us back to the indifference curves that we studied at the beginning of this course. So what does exchange between individuals improving the outcomes of both look like? So let's consider Alice and Bob, and they have each an endowment of apples and bananas. And in this society consisting only of Alice and Bob, there is a total of 10 apples and 8 bananas, but Alice starts with an initial endowment of 3 apples and 5 bananas, whereas Bob starts out with 7 apples and 3 bananas. So Bob has more apples, Alice has more bananas. Question is this a Pareto efficient allocation? Well, it's impossible for us to answer this question because so far we don't know anything about Alice and Bob's preferences. Specifically, we don't know to which extent they like apples and bananas and are willing to trade apples for bananas or vice versa. So let's first consider the preferences of Alice by just writing down or graphing a couple of indifference curves. So on the x-axis we have the apples, and we have the 10 here because in total there are 10 apples available in this society. In total there are 8 bananas available in the society, so we put that here on the y-axis. And these pinky curves are some indifference curves of Alice. So you can see that they're nicely convex, no corner solutions here. Probably Alice will prefer some mixture of apples and bananas because the indifference curves are nicely convex. Now then we have Bob, and Bob also has preferences for apples and bananas. He also has nicely convex indifference curves, so judging from the indifference curves, we don't expect Bob to prefer extreme outcomes of allocations with only apples or only bananas. But yeah, studying these two individuals in isolation is one thing, but in order to get to Pareto efficiency and to study that, it's optimal to put both indifference curves of both individuals in one graph. So this is what we are going to do, and we are going to flop the graph by Bob 180 degrees. So we just twist it around and then put it on top of the graph for the indifference curves of Alice, and you get a resulting figure, which in the first instance may be hard to read, but once you get the idea, it's quite simple. So as before, Alice's utility is increasing when she moves from the origin towards the top right corner, because then she gets more of everything. But for Bob, notice that we twisted his indifference curves. So this is the point where he gets 0 bananas and 0 apples, but Alice would get all of the apples and all of the bananas. And Bob's utility is increasing as when the allocation moves from the top right to the bottom left. So his utility is increasing if you move in that direction. So this box, which is called the attribute box, represents all allocations of apples and bananas in this economy that are possible between Alice and Bob. So for example, at this point over here, you have the allocation. Alice has 8 bananas, Bob 0. Alice has 10 apples, Bob 0. And if you would be at the point, say, somewhere over here, at this point, you would have Alice has 4 apples and say 6 bananas, and Bob has the remaining bananas, so he will have 2, and he will have 6 apples. So all the points in this box, this attribute box, you can just make dots, and each dot will represent an allocation of apples and bananas between Alice and Bob. And that allows us, together with the indifference curves that are shown, to say which of these allocations, which of the dots are Pareto efficient. So for example, if we take the point A, this is the initial allocation. So this is the allocation where Alice starts out with, I think it was 3 bananas or 3 apples and 5 bananas. And Bob started out with 3 bananas and then 6 apples. So Alice has 3 apples, 5 bananas, and Bob has the remaining bananas. So he has 3 bananas and he has 7 apples. So point A is the initial allocation. This is what they have to start out with. And then the question is, are Pareto improvements available? Can they trade apples and bananas in such a way that makes them both better off? Better off within the context of our course means, can they reach an allocation that gives each of them a high utility? Well, you can see that at the initial allocation A, Alice is on this indifference curve because it runs through the initial allocation, and Bob is on this indifference curve that also runs through the initial allocation. So can they be made better off? Well, to find the answer, let's zoom in a little bit. So now we zoom in on this area that are between these two indifference curves, which is this area. And you readily see that if instead of allocation A, Bob and Alice would reach an allocation that is within these two indifference curves, then both of them would arrive at a higher indifference curve. So if you look at the point where the arrow now is, and you would draw the indifference curve of Alice that runs through this point, then that indifference curve would be one associated with a higher utility level than the initial indifference curve. And the same for Bob. The indifference curve that runs through this point over here would be associated with a higher utility level than the indifference curve that runs through the initial allocation A. So, by moving to the southeast, both would become better off. All these allocations are associated with higher indifference curve, both of Alice and of Bob. And it is feasible as well, because the attribute box gives all allocations of apples and bananas. And Bob and Alice have these bananas, so they can freely trade among the two of them. So all such moves would constitute a Pareto improvement. Natural follow-up question here is, when are all these mutual beneficial trades exhausted? So is there a point, or are there points where no trades, further trades can be imagined that make both individuals better off, or that make at least one of the two better off without making the other worse off? Answer is yes, such allocations are there. And more specifically, those allocations are the allocations at which the indifference curves are tangent to each other, like in the point A that is given in the graph over here. So here you can see that at this allocation, the indifference curves are tangent, and if you would move in this direction, you would make Bob better off, but you would make Alice worse off. And if you would move in this direction, you would make Alice better off, but Bob worse off. And also if you would move somewhere here, you would make both individuals worse off. So a point B over here, if you draw the indifference curve that runs through them of Alice and Bob, both of the indifference curve would be associated with a lower utility level than the two indifference curves that have been drawn through point A. So we have reached an outcome of Pareto efficiency when the slope of the indifference curves are equal. Now, when does it hold? It holds when the marginal rates of substitution are the same for both consumers, for both Alice and Bob. So in formula, we reached an efficient allocation if the marginal rate of substitution of Alice equals the marginal rate of substitution of Bob. So the ratio of the marginal utility of apples and bananas of Alice must be equal to the ratio of the marginal utility of apples and bananas of Bob. But we know from the previous lecture that when Alice is confronted with the price of apples and bananas, she will buy from her budget just the amount of apples and bananas such that the marginal utility of apples and bananas, the ratio, is equal to the price ratio of the two goods. Bob, being in the same market, being confronted with the same prices of apples and bananas, will do the same. He will buy apples and bananas in such a way that his ratio of marginal utilities of apples and bananas equals the price ratio of the two. So they equate the marginal utility ratios, the marginal rate of substitution, each independently to the same price ratio. And by equating them to the same price ratio, this ensures that also the marginal rate of substitution of both individuals must be identical. So, to reiterate, given prices of apples and bananas, each consumer independently will make sure that his or her marginal rate of substitution equals the ratio of the prices. That implies that everyone's marginal rate of substitution will be equal because all individuals in society face the same prices. So, by the price mechanism, we will reach a Pareto efficient outcome. And this is one of the wonders of economic theory, that it shows you that if you just have the price mechanism and everyone is free to buy and sell goods given his or her budget, the equilibrium allocation that will be reached will be the one that is Pareto efficient. So can we cheer, relax, and really be happy about market outcomes? No, not really, because the efficient outcome is not unique. There's more than one efficient outcome. So there are many points in this Edwards box, many dots, many allocations that are Pareto efficient. So if again we look at the situation of Alice and Bob, then there are multiple points in this Edwards box where the indifference curves of the two individuals are tangent to each other. So in this graph here, there are 3 of these points depicted. So these 3 green points are 3 Pareto efficient allocations, but in fact, in a setting like this, you'll have an infinite number of them and you can connect all the Pareto efficient allocations. So this green line that is given here is the set of all Pareto efficient allocations. And the green line has a special name. This is called the contract curve. It's a very nice result, but it raises another question, and that is, okay, given that we have a set, this green contract curve, an infinite set of Pareto efficient allocations, which one is optimal? They're all Pareto efficient, so this is also why I call the concept of Pareto efficiency a rather weak concept, because it gives us many efficient outcomes, and it doesn't allow us to distinguish which of these efficient outcomes is better or worse. And you can see that some of these efficient outcomes, despite being Pareto efficient, are not very nice for all individuals in society. So if you look at the extreme cases, you can see that the origin at Alice and also the origin at Bob both belong to the Pareto efficient set. So if you have as an initial endowment the situation where you give Alice all the bananas, so 8 bananas, and also all the apples, 10 apples, then this outcome is Pareto efficient. Bob doesn't receive anything, but it is efficient because there's no trade possible that can make Bob better off while not making Alice worse off. Because in any case, Alice needs to give away something to Bob, getting nothing in return. So in given Alice preferences, that certainly will lead to a decrease in her utility. So the extreme outcomes where one person gets all and the other one person gets nothing is also a Pareto efficient outcome. So that's the situation that is drawn here. So outcomes may be efficient, but from other considerations that you may have, you may not deem them fair because they're not very egalitarian. So Pareto efficiency does not have anything to say about the fairness of a certain outcome. That brings us to the third quiz, which is to consider an attribute box, and we have Lou and Thelma, and they are the two persons in this economy, and there are also two goods in the economy, soda and pizza, and there are 3 questions to answer. So at point A in the attribute box, which is given here, how much soda and pizza does Lou have? How much does Thelma have? Question B, suppose that taking point A as the point of departure, and we take 2 pieces of pizza from Lou and give them to Thelma, and at the same time 2 sodas from Thelma and give them to Lou. Is that a Pareto improvement? Third question, very similar. Suppose that we only transferred 1 unit of each. Is that a Pareto improvement? And explain this by plotting new indifference curves.